So if you're a 2000s kid like me and you grew up with DVDs, you probably remember very well this sound. This sound has so much history, and I don't think very many people know where it comes from or why it was made. For me, this sound was both a bit cool and a bit scary depending on the context. It just has that otherworldly vibe that can be both alluring and off-putting at the same time. If you don't know, this sound is called the THX Deep Note, and it was created in 1982 by Dr. James A. Moore at Lucasfilm. The goal was to test theater sound systems to make sure that they were playing the best quality sounds possible. At that time, a lot of theaters were still playing sounds in mono, and George Lucas wanted to make sure that theaters had the best sounds. Why?
Return of the Jedi has opened here in New York. It was Astor Plaza at 8:30 this morning, and even at that early hour, the line was 5 football fields long.
I love these movies, they're great. I just want to see the movie. I want to see it before everybody else does.
I spent a lot of money on some of the special effects.
Yep, this was to help hype up the release of Star Wars Return of the Jedi. To me, this is one of the coolest sounds ever, and it has both an aura of mystery and wonder. So today, we're going to create in JavaScript. Let's start with what I'm going to be using for this project. Firstly, this is a front-end only project. I don't have any back-end databases set up because I don't really need them. So I'm going to be using vanilla JavaScript, Bootstrap 5, HTML, and CSS. I'll also be using VS Code as my editor because I love VS Code. All my snippets and extensions are in VS Code. It's cool, you're cool, we're cool, don't judge me. The biggest tool we're going to be using here is the Web Audio API. This tool makes the entire project possible, and it's used in 90% of the entire codebase. And I'll explain why later. Now that we have our tools ready, let's go over how I organize the project. I really like having effective organization. Some people get really granular and have folders for every single file case, but for me, I keep it simple. I have a source folder, then in that I have an audio folder and a UI folder. The source folder, as the name suggests, is where the code is stored. This isn't for CSS, this isn't for HTML, just the primary JavaScript. Then, in the source folder, we have the THX Deep Note file and a UI folder for the DOM controls. There's also an audio folder, but that's for custom sound generation, which we're not going to focus on. Our focus will be on the THX Deep Note.js file in the source folder. Alright, so let's think about a couple of things here. When we listen to the original Deep Note, it starts chaotic at first, but then it resolves into this nice lovely chord. That's obvious, but the question is, what is random in this context? What ranges are we using to determine what is random? And how does it all resolve into that beautiful chord? Luckily, we have a framework provided for us by Dr. Moore himself. This is the sheet music for the THX Deep Note. As you can see, we have different sections here that tell us exactly what the notes are supposed to do and how they're supposed to end up at their final chord. Basically, the Deep Note starts with a cluster of 30 notes, like 30 different frequencies, all kind of fighting each other. Then, over time, they slowly glide into a clean, powerful chord. The original used a mix of randomness and control. The starting frequencies were random with a range, but they all hit a target destination. What I have to do in JavaScript was replicate that gliding behavior. Now you may notice that the THX Deep Note has both a symphonic and a digital sound, and there's a reason for that. This is where the Web Audio API comes in. The API provides something called an oscillator, which we will use as our instrument to generate the sound. But what is an oscillator? Oscillators are digital tone generators that are programmed to generate specific sounds at different frequencies. Think of an oscillator like a digital tuning fork. It creates a very basic sound wave, and it plays that wave over and over at a certain frequency, which we hear as pitch. There are 4 types of tones oscillators can generate: square, triangle, sine, and sawtooth. You may recognize some of these, especially the sawtooth, as it was very popular for synthesizers and it was featured in many popular music tracks from the 80s, such as... Oh yeah, Van Halen's Jump, released in 1984 on the album 1984. So to get that brassy classic THX sound, I decided to use a sawtooth. According to Dr. Moore's sheet music, 30 voices start at random positions between 200 Hz and 400 Hz. So we need to generate each of these voices and give it a random frequency to start. Alright, so the whole thing is created and managed by this create THX buffer function, which takes in an audio context and a duration as its parameter. In this section here, it checks to see if the audio context exists, it generates the final D major chord, it sets the center frequency, and then divides all the 30 voices between and around that center frequency. And then down here you have the stuff for the gain and the filters. And then you have the oscillators, which declares what type of oscillator, the volume, and where they're going to start, where their starting positions are going to be around the center frequency. Down here you have the sections, which tells which section does what in the sound. And then you have our for loops that control everything else. And we'll dive into this section a little bit more later. You might be asking what these are. These act as the variables for my high pass filters, low pass filters, and volume. They don't really have anything to do with the sound generation, but rather add a little bit of polish to the final sound. To start, the master gain is the volume and manages, the sound's volume. Now the high pass and low pass filters are a little bit different. They don't help in the sound generation like we said before, but rather they help shape the sound by letting some frequencies in, but blocking others. Here's how it works. High pass filter. This one only lets through higher frequencies and it blocks the lower ones. Imagine a filter that lets you hear the higher pitched brighter sounds, but mutes the deep rumble of the lower notes. It's useful for cleaning up any of that unwanted low frequency noise or rumble in our sound. Think of it like a way to get rid of any unnecessary boominess at the bottom end. The low pass filter. In contrast, the low pass filter only lets through the lower frequencies and it blocks the high ones. This is useful for smoothing out the sound, especially if there are any sharp, harsh, high-end tones that don't fit with the rest of the harmonic content. It's like turning down the treble on a stereo system and allowing the deep, rich bass to shine through. So why did I use these filters? Well, remember, the THX Deep Note is supposed to sound clean, yet powerful. These filters help cut out anything that might make the sound cluttered, thus giving it that smooth, professional appearance. The high pass clears out any unnecessary low-end noise, and the low pass makes sure the high frequencies don't get too shrill. Together, they let the sound breathe while keeping that powerful, eerie vibe that we want. Now that we've cleaned up the sound, let's go back to generating those 30 voices. Alright, so again, we're back into the THX Create THX Buffer section. So we already know the final chord is generated with 30 voices. Center frequency is right here, and then the initial frequencies, it's created as an array of 30. That's how we get our initial frequencies. But then we come down here, oscillators, initial frequencies.map, start frequency, which means that all of our oscillators are going to be mapped to the initial frequencies. Then you have the oscillator, which is equal to CTX create oscillator. That's actually how the voices are created. And then the voice gain is actually how we give them volume. And then os.type is how we select it to either be a sawtooth, square, sine, or triangle. And we'll get to this section next. Now that we have the voices generated, we need to tell them to move randomly for a while between these two frequencies. This is where the first issue came in. I would tell the voices to move randomly, but they would jump directly from one note to the next and not escalate and de-escalate slowly to their target frequency. This is where the method linear ramp to value at time comes in. What this method does is, instead of telling the browser, jump from this note to this note, it tells the computer, go from this note to this note, but take your time and hit all the frequencies before your final note. Alright, so this is the place where they're used most, okay? So, if we have a section where the notes are moving directly from one frequency to the next, we use this method with the end frequency, which is the target, as one variable, and then the section end time as the second variable, which is basically telling us how long this change should last for. And then if it's random, we have a random frequency plus the time plus step time. And time is the current time plus step times the step time. So once we're done setting these up, we should get a perfect glissando from one note to the next and not an instantaneous shift. Okay, the final blasting chord. We got the random start positions, we got the random movements, and the notes are ready to make their final transition. But what are they transitioning to? Well, the THX DEEP NOTE is commonly understood to resolve to a D major chord, which is D, F sharp, and A. But this is where we had another problem. Yeah, just telling the code to land on certain frequencies doesn't really work for musical chords. So what we have to do instead is assign notes to certain frequencies and then detune them slightly in order to fix the issue. This is where the generate D major chord function comes from. So to start, we have the three separate notes, the D, F sharp, and A. And then we have the notes array, or the notes array, my bad. Now what this does is, this is for the 30 voices and getting it to divide amongst these different notes, because in the sheet, there are some notes that are specified to certain frequencies. So you can see D divided by 2, yada yada. Then we have an empty chord array. Then for every single voice in the number of voices, we select the note divided by, or the remainder of note times length. Then this variation here is what gives us our slight detuning. Then we push the chord times its push the note times its variation. So now we have multiple voices playing multiple notes, and we have some slight detuning in order to create that beautiful note. Now we'll quickly cover the section portion. The way that I see it, the sound has three major sections. The random start and traveling of the notes, the transition to the final D major chord, and then finally the playing of the D major chord. Alright, so here's the sections object. It's an array of objects, and it shows things like the duration, the mode, whether the notes need to travel randomly or not, and the range, which is the center frequency times the variation, and then you have others that do the same thing. Now, for each section, it calculates the section end time, the oscillators and what they should do, what the oscillator should do if it's direct or random, etc., etc. So basically, you can put in as many sections as you want, and then this will take care of all the rest. And that's that. Let's see if it's anything close. Okay, that was awesome. Alright, okay, it wasn't perfect, but it was pretty dang close. What you have to understand is that while both of these sounds were procedurally generated, I'm working within the limitations of a web browser language. If I had more time and resources, I could probably get the sound a lot closer. Another thing to consider, although I'm not sure, is that the original sound file may have also sounded pretty close to this, but they doctored it up in a DAW, or a digital audio workstation, for production use. If anyone could confirm or disprove this, please tell me so in the comments. With that said, I did leave a button for you to press to download the WAV so you can see for yourself. It's also important to consider that this sound isn't just a sound, it's history. It wasn't made to be the marvelous wonder that it is today. It was originally made just to see if theaters had a good enough sound system for Star Wars, but the result was something that lasted generations after its initial purpose. THX.com has a section of the site where you can play their Deep Note with a visualizer, and it's really cool. I recommend that all of you try it out. I'll let you know also that this project is open source and on my GitHub if you want to play around with it yourself. I've also added UI where you can create your own oscillator sounds as well. I hope you enjoyed this video. If you did, please leave a like and subscribe, and stay tuned for more cool stuff like this. Times are tough, with rising costs for food, gas, housing, you name it. It's harder than ever to keep your money where it belongs, in your pocket. That stress, I get it. It's overwhelming. That's why I'm working on Trinity Capital, the ultimate app for learning financial literacy. It's super realistic, with a clean design and built-in lessons to help you master your money. And the best part, it works on any device with an internet connection. Right now, you can test it for free. Join the Discord server, try it out, and help shape the app while it's still in development. The link's in the description, so check it out.